Welcome back to the Obi-Wan channel. We are here with the 65F100 because it's always fun. And I guess I did a little bit of work yesterday. Actually, I've been doing a little bit of work for quite some time, but I definitely did a lot of this yesterday. What this is that I'm talking about is we are getting ready to wire up for the radio system. So, I think I may have had a video of this already, but just a real quick recap. You can see here I've got this superstructure up here out of aluminum 1x1 that I put up here, and you can see I cut this panel and I got my radio, my head unit, my old school booster equalizer. Then I'm going to have this USB kind of charger, but it'll have the voltage right there. Because right now, I don't have my key in, but right now I have this little voltage meter here, digital voltage meter that I don't know where I got this thing, but I've had it for a long time. And when my alternator got changed over to a one wire, that alternator light quit working, and I really didn't know how to know if I was charging. So I decided to install that real quick, go back here on the back of the switch for my source, and that tells me what the voltage is. But as soon as I get this one functional, that one will come out. Then I got a 3 OSB type charger system here, as well as the C-Hub. A lot of iPhones use that, so that's why I wanted to do that. And then of course I got a cigarette lighter charging port right there. So all of that is going to be powered up here really soon. You can see I got everything all kind of wired up back there, getting kind of ready. So what's going to happen here, or what did I do yesterday, I guess? So yesterday, basically, I took and I mounted all these relays. I had the relays, I guess, mounted, but I mean, I really got them all wired up at this point. So what I did is I had to kind of redo some of my wiring that I already had here. Again, you can see my one wire alternator right there, GM frame. That the people before me had a GM frame, so I just stayed with that design because it works, and also it's more popular, so makes it cheaper, and I can get a replacement much easier probably. So that's why I stayed with that. So I had already this yellow wire here in place because that's part of my electric fan relay that I had already installed in here, and it needs a source from when you turn the switch on. So this relay needs to know that you have the switch in the on position, because if it doesn't, obviously this fan can turn on and off even when you shut the vehicle off, which you don't want it to do that because you don't want it to run your battery down. So what I did is I'm using Sermos, or I keep calling them servos, but they're Anderson power pole connectors. Basically, these housings right here are, they're plastic, obviously, but they are good for up to 45 amps. But when you look at the little crimp connectors, or they're silver plated, I guess contacts. There you go, silver plated contacts, and they come in a 15 amp, a 30 amp, and a 45 amp version. Basically meaning that, the contact itself is silver plated, and it's the same size no matter which one you choose. It's just the part where you stick the wire in and crimp on gets smaller or bigger depending on the size. So basically this same housing is rated up to 45 amps all the way down to 15 or whatever. And again, I've used these on RCs forever, and they've been wet, they've been hot, they've been all that kind of stuff, so it works out really good. And they come in different colors, but you can see here I'm using red quite a bit. So that's kind of how I'm using, working all this. But as I was saying, this is the hot for when you turn the ignition switch on. And so as you can see here, I kind of tied in a little jumper, so that way this yellow wire continues on on the one side over to the relay here for the fan, and then on the other side it goes right here to this wire, which comes over here to this relay right there, and will activate this relay. Now this relay happens to be a pricey one. Maybe I'm overthinking this, especially given the fact that this is the 1965 truck and all, but this relay right here is weatherproof because it's got the rubber in there. It's actually already broke that tab, which I don't think is going to be a problem because that rubber is so tight. This thing's not going anywhere. Even after many miles and shit of vibration, I doubt it'll ever pull out. But it's weatherproof. It's supposed to have a clip there that broke off, unfortunately. But what's special about this relay is that it has a diode. So basically what I understand is when you use these kinds of, any kind of relay for that matter, when you use them and you power them up to where the actual coil goes and, snaps in, and it energizes and it snaps in, the actual relay itself. Well, just like a coil here, ignition coil, when you warm it up, and then of course when the points or the electronic ignition actually, breaks open the points, so to speak, right? It collapses the coil, and the coil goes to high voltage, which is, kind of how you get the big spark on your, spark plugs and wires and that kind of stuff. Well, the idea behind this is if you don't have the diode in there and you go to turn off your ignition switch, for example, it has kind of a voltage spike that goes back into the system, and it goes back to the ignition switch, which could, over time, cause, the actual ignition switch contacts to, carbon up, burn up, so to speak, because you keep, turning this thing on and off. You keep collapsing that coil every time you turn the ignition off, right? And it's probably not a big deal at all when it comes to just one relay, because these relays here do not have the diodes in them. Okay, these are just your typical relay where you apply power to it and it will energize the coil, snap the contact shut, and then when you turn it off, it obviously collapses and opens up the contacts. Well, again, when you have like one or two relays, probably not a big deal, but I've got 3 relays here, and there's probably going to be more, by the way, that I will put in here over time as I add more electronic items and whatnot. And when you do that, so let's just say I had that ignition switch wire come over here and I had it energize this one, and this one. And now you've got 3 coils that are energized up. And then when you turn the ignition switch off, all these coils here will now backfeed into, the actual wire that's coming from the switch. And again, like I said, when you read what you read and you understand what supposedly is happening in theory, it's going to cause, arcing and sparking in your switch as the contacts try to open, and could, again, put a lot of wear and tear on your switch. So what I have done here is I have, again, because these are more pricey, I've only bought one of these, the fact that it's weatherproof, that really wasn't what I was after, but guess what? It happens. I mean, yeah, it's under the hood, right? You should probably have a weatherproof one here, but I don't plan to really drive this thing in, like a shit ton of rain or through water puddles and that kind of stuff. But my point is that it is cool that it is weatherproof. These actually do have 12 gauge cables for the big, for the high power side. So that's cool, because these right here were a little bit cheaper, but they have, what I like about these is that they actually have, I don't know if you can see it, but right there, they actually have like a fuse, I think it's ATM fuse that you can put in here, and they come with 30 amps, by the way. I just got them pulled out so that, because right now I'm not using them, so I got them pulled out so that even though this thing here would energize these, there's not going to be any 12 volt power going through those wires at all. That's why I got the fuses pulled. Plus, 30 amps is a little bit big for, what I'm powering here, and I'm going to get some, correct size fuses and put in there obviously, again, after I get everything hooked up, that is when I'll start putting fuses in here. But point being is that, again, this is 12 gauge wire. These are 14 gauge wires, but they are rated to 30 amps. This one here is rated 30/40. And again, much definitely, just because of the wire is actually a 12 gauge wire coming out of there, it is definitely a much better relay. I would have spent, so like for these, I think I bought a pack of 8 of these for like, I don't know, like 25 bucks shipped. And I think I paid like $12, $11 for just one of these. So, I just, again, like the idea that these already have fuses on them, so that way I can actually fuse the wires properly right here at the source, rather than having to do something like this, put an inline fuse in, okay? So, all right, let's get to the nitty gritty. So basically, I've got that wire coming from the ignition switch to activate this one. Then, after this one, you can see it comes over to here, and you can see how I jumpered all this right here. And if I start adding more relays into this, group right here, all I got to do is, with my Anderson power poles, is just add another, jumper here, basically, and I can all, slide it all together. It looks, neat. And when I unplug it all, it unplugs everything. Now I can plug everything in, individually. That's one way I could do it as well. But, again, this just looks nice and neat in my opinion. And it just kind of keeps everything from, flopping all over the place. So it comes over here and it activates all 3 of these relays right now, which is the only ones I need at this current moment. Okay. Now, so these relays, as you can see, are kind of all grounded right here. Comes over here, goes over to this ground bus bar. Okay. And that's how you activate the coils on these 3. Then you can see I've got the power source for each one of these right here at this hot bus bar here. And then after that, you can see I got one that I haven't quite hooked up yet. And you can see where I'm going to hook it into here. But you can also see that I got one hooked up to this wire here, and I got one hooked up to that wire in here. Now this is, I believe it's I can't remember what brand it is, but it is a supposedly a direct burial 14 gauge pure copper. That roll of wire, I think about over 100 feet. That roll of wire is pretty heavy, actually, when you pick it up. So I'm pretty sure that this is actually pure copper, this wire right here. I think a lot of this stuff right here in these relays and whatnot are the CCA copper clad aluminum. But again, being how they have such short little runs, it's really probably not going to affect anything at all anyway. So, but I bought this right here mainly because I have the secondary wire jacket. Obviously, I'm not direct burying this stuff, but I wanted at least 14 gauge wire for a lot of the power stuff inside. And being how it's copper, pure copper, that helps a lot, right? So it makes it to where, it's conductive, very well conductive, compared to copper clad aluminum, which it really doesn't make a huge difference. But hey, listen, I just had the ability to get it, had everything that I needed all in one package. So that's why I went with it. It just so happens that it's pure copper wire, 14 gauge, which would, if it would have been copper clad aluminum, I probably would have moved up to 12 gauge, but 14 gauge, great. And again, it has this other secondary jacket over the top of all this stuff, which I like because, again, it's going to be out here exposed underneath the hood, and it's actually going to go through the firewall. Now, of course, I'm going to put it right through there. I got to take that choke cable out because I don't have a choke on here. The cable's sitting there, but it's not actually functional, and I never use it because I don't need to use it. So I'm going to be taking that out. And you can see here that I kind of made these to where one's a little bit shorter than the other. What that does is that helps you to be able to feed this stuff through that smaller hole, basically. So, and that was, again, the other reason why I like the idea that it had this extra outside covering is because even though that is a rubber grommet right there, going into the firewall area, it will be not just, the actual, like for example, you have the wire and you have the wire insulation. Most people will just stick that through there, kind of like I did right here with this. This right here happens to be my tack feed coming out here over to the coil, but you can see that I don't have it, protected per se. And it's just because it's such a small wire, it's not really going to bounce around or rub on anything. Plus, it's, rubbing on rubber, if anything at all. But what I'm going to end up doing here is just running that like I did there, and then take these and push them through that hole. And then now, what I have to do, come inside here, and I got to bring that stuff through the hole in the firewall, which is right there. And then I'll kind of run it over there above the brake pedal and the clutch pedal and all that shit. There's like a hole right here, and then it'll start to go up into this this pillar channel here, and we'll come up and over, and we'll go right there and bring all the power to everything from this side over here. And then all the speaker wires and the line output for the subwoofer that's going to land underneath this seat here at some point, all that stuff is going to go that way and down that pillar. I'm trying to keep all the the dome light, the fuel. I got a wire right here. This is the fuel sender right here for inside the cab, which of course that'll end up leaving at some point, because I'm going to, when I get the other frame, I will end up putting the fuel tank in between the frame and the back, so it doesn't smell like gas in here. And I don't have to, and I also gain more room back here for a bigger speaker box or storage or whatever I want to do. But I'm trying to keep the speaker wires and the line input wires separate from all power wires, so we get a little noise interference at all, which also, again, was the big reason why I chose to go with copper wire, because copper wire, again, better conductivity. It shouldn't have quite as much electrical noise as something that has more resistance to it. And also, again, another reason why I went with that double jacketed. So you've got the insulation over the wire plus the outer jacket that goes over the top of that. It's just another layer of insulation that's over the top. So if I do happen to decide to take a chance and run one speaker wire down this side for this side of the vehicle, I can do that. And hopefully, because again, it's copper and it's got that extra layer of insulation, it won't transmit noise through it, and it won't be displaying that in the speaker. But you know what? Honestly, I think I'm not going to do that. But it was, something that I thought about when I bought it. But I think all my speaker wires and lower line inputs are going to go over to the passenger side. And then I'll just bring that speaker wire all the way back across for this side over here. Because actually, when you go and you look at a lot of online forums and everybody, guys that are doing this for a living, and they show you how they do, their setup, they generally follow the speaker wires in one direction, and it might, again, this is a truck, but think about it. If for example, if I actually put the radio where you probably would want it or should put it, would be right there, and it wouldn't be actually such a big deal what I'm doing now. But when you talk about cars, I notice what they do is they have the radio in the center, of course, and then if they got speakers back there, they run all the speaker wires to one side, and then they run it all the way, to what would be the trunk area, and then they curve it around the trunk area and then come back to grab, the back speakers, and then they just go over to the, it's vice versa. It can be driver or passenger side. It really doesn't matter. But my point is that they tend to just go to one side, and they grab both the left and the right off of one side. And again, the whole purpose of that is just keep the speaker wires and line inputs and all that stuff away from anything powered. So, as an example, this right here, my car, I haven't started wiring it yet. I'm trying to make a decision right now. My big kind of holdup is, am I going to put my, because I'm going to do an aftermarket Speedway 22 circuit universal wiring harness in here. And I haven't decided if I'm going to put my fuse box right there where, it was from the factory, or if I'm going to put it over there by my glove box or inside my glove box, or if I'm actually going to put it back here behind the back seat, because I'm actually remotely putting the battery in the trunk. So the battery is going to go over on that side of the trunk. And so that was one of the reasons why I was kind of thinking about putting it back here. But of course, before I go saying, yes, that's what I'm going to do, what I need to do is I need to get that actual wiring harness out, and I need to actually place it there and see if I can run all the wires up to the front, etc., without doing a whole lot. But my point that I'm making is that in this situation with the car, one of the cool things that you have here, and can't really, no, and I don't have my door handle hooked up right now, so I'm not going to mess with it because I don't want to bump paint wrong right now. So anyway, my point is that they have a channel that runs right here and a channel that runs over there. Now with the old 65 truck, we don't have that. So you open up the door. This is just like a piece of trim here that's sitting here, but if you actually take the door sill trim off of the Mustang, you actually have a channel that flows underneath there that you can hide some wires in. And I actually did that back in the day when I was driving this in high school. I hid a lot of stuff there, but I also, honestly, just lifted the carpet up and threw it underneath the carpet too. So there's that way of doing it. But when I go to do all the wiring to this car, it's either going to be up here into the pillar, or it's going to be down there in those channels. And, again, when I go to do the stereo system, same situation. It's probably going to be exactly what's going to happen, actually, very similar to that one, is that I will run the wires for like everything powered, tail lights, reverse camera, all that stuff will probably go over to the driver's side to the back. And then everything for speakers and shit will fall into that track. You can almost see the track right there on that side. But I will run all the speaker wires and everything, that could get noise in it for the stereo system over on the passenger side, basically. But what's cool about this is I've got that channel down there, that channel, and I got two pillars to go up here into the attic area. So, but I don't want to put a whole lot of stuff up in the attic area just because it's a lot more difficult once the headliner is in and the pillar molding and all that stuff to be able to work with that. But anyway, back to the F-100. You can see what I have actually done. And now, like I said, all I got to do is poke those through the firewall. And then I'm going to take that same jacketed wire right there. And I'm going to, and that was the other reason why, by the way, getting ahead of myself here, but that was the other reason why I put these Anderson power pole connectors in here, is because I'm making this because I know that when I get my frame over here and I actually rebuild that entire frame, what I'm going to end up doing is that, rebuild all the frame, the axle, the front end, get the powertrain put in, all that. Then I will actually lift this thing off and put it over onto the new frame. Because this one here, for example, I want to keep this thing running as long as possible, and I really don't want to put any money into this frame. But I'll tell you what, man, that gearbox is getting kind of sloppy. I've adjusted it several times, the high point there, and it works every time I do it, but it just starts getting looser later. The front brakes over here on this side keep locking up on me every once in a while, and it's also groaning. So I figured that, either the grease seal is leaking or maybe some brake fluid is kind of leaking. I don't know, but I just don't want to put a lot of money in this. I know all my rubber bushings underneath this thing is just shot. And I do have some rust to address when I actually lift this thing off and move over to the other side. But the whole point that I'm making here is that one of the big reasons why I'm using these connectors here, again, silver plated, handles up to 45 amps, which, there's really, it's going to do everything that I'm going to do. I got a 100 amp one wire alternator. If there's anything that's over 100 amps in here, I'm already at a disadvantage because of the alternator. So, but yeah, I've actually got a amp meter that I put on this thing, and I had the electric fan, this thing running. I had the heater fan blowing at full blast. I had the power of the lights on and everything, and I think I was at a max of almost like 30 amps. That's about all I had running through the entire electrical system at that time. So using these connectors that they're more than rated for, but when I go to swap this thing over to the frame, if I were to actually, solder shrink everything, then when I go to remove all this stuff that I've just added, I'm just going to have one great big cluster bang of a wiring mess is what I'm going to have. Imagine if I just solder crimp this, like I'm doing here, solder crimp with the shrink tube and everything, or even just a crimp and putting, like shrink tube over the top of it. And imagine if I did that all, with everything here and then take that wire and just run it all the way up there to the top with one piece of wire, two pieces rather, but you know what I'm saying. Now, imagine when I go to take this thing apart to lift it off, to do the work to it, and then swap it over to the other frame, you have just this huge, one-piece wiring mess that you will definitely, to make it easier, you'll end up just snipping. You'll end up snipping all that stuff here and there. So I took the liberty to, again, in thinking in advance. And, again, there's going to be some that will say, well, every time you make a cut, every time you make a connection, you have a voltage loss or whatever. And that's exactly why I'm using the Anderson power pole connectors, the Thermos power pole connectors that have silver plating on them. I have already done my voltage drops, actually testing, right here off the top of the battery through a lot of these connections just for testing, and I have absolutely none, zero voltage drop. So again, you use the right connector, you use the right wire, you gauge everything properly, and you will be just fine. But again, the big deal for doing that is now when I go to take this thing back apart, all I got to do is unplug the upper wiring from this wiring here, and I can take out the interior. Then I can unplug this stuff right here, and then remove all that stuff, and that will be one piece, and I'll be able to separate all this stuff away from the wiring that was a part of, the truck. I will be able to keep it away from the actual fan here and the fan relay, so when I take that stays separate. Again, it takes a lot of work, because, you got to think about this stuff, and obviously more of an expense, because obviously them butt solder connectors or even crimp connectors with some shrink tube is a lot cheaper than, buying those Anderson power poles. Those suckers aren't cheap, by the way. They're at least $1 a connector, but again, they are the best, as far as conductivity with that silver plating, so that keeps it, to where they're not corrosive, so to speak, and very high conductivity. By the way, I am putting just another thing to talk about real quick. Every time I take one of those little contact clips and I crimp, which I'm using an actual professional crimper, by the way, whenever I crimp them on a wire, the wire gets dipped into dielectric grease, by the way. Really, I mean, like I stick it in there and I really make it coated really well. And sometimes I even put a little bit inside the actual contact connector, put them together, stick them in the crimper, the professional crimper, and crimp them down. So every single wire is not just a dry copper wire or, copper clad aluminum wire. Everything is actually dipped in that dielectric grease. I put the dielectric grease, even though this is a weather tight seal, I put it inside those connectors in there. I put the dielectric grease, just gooped it up inside these connectors and then plugged it on to these fittings here. And I also put it right inside here. You can't really see it, but right here where the fuses go, I just dumped a bunch of that stuff inside there. I don't I've been touching these things all the time, so they're not really rubbing off on me anymore. And then every time I take, I haven't hooked these up yet, but when I do, I will actually put a good glob of that dielectric grease right inside each one of these connectors and slip them together. So not only, again, is it, silver plating, which is really good for, conductiveness and corrosion control, but putting that dielectric grease on there is going to do even, more for protection and whatnot. And I do that with every single thing that I crimp. The only time I do not use that grease, obviously, is when I do the solder shrink connectors like this with the, so you put the two wires together and, you hit it with the little torch or the electric heat gun, whichever one I was using at the time. Just kind of depends on, honestly, if it's easier to use whichever one, because sometimes I find that little torch is a lot easier to use in tight spaces. You just got to be careful what's in your background so you don't burn it all up. But my point is that, you get these, what I usually do is I usually take the wires and then I usually take my soldering iron and I tin both, I strip and I tin both ends of the wires with the solder. And then I slip over the connector, the butt connector with the shrink stuff in the middle. And then I use my electric heat gun or torch, whichever one. And then, of course, it just, shrinks around. And you can tell when it's actually really nice and tight. And it kind of looks like it just glued itself onto the wire. And then you can also see when that center solder starts to melt and it goes into the existing solder of the wire that you just got done tinning, and it seems to make the absolute best connection. And again, I'm testing this stuff by either doing continuity checks or again voltage drops across every connection. I just want to make sure that there is no reason why we are going to have any kind of problems or intermittent little things later down the road, because it's best to do it now as you keep on doing this. Because if you just put it all together and it just happens to work, okay, that's great, but what if you start having trouble? How are you going to really know where the problem is? You've got a lot of connections that you have crimped and soldered, etc. And where do you start, right? Okay. All right, and just to kind of close out this video, just real quick, kind of give you an idea of what's going on here. So again, this is the major control relay, which controls all these relays. It has the diode here that when I turn off the switch over there, all of these coils collapsing come back to here and hits, and it will affect the contacts inside of here instead of my ignition switch in there, which I would rather do because I can replace this, in my opinion, a lot easier than I can that. And also these are usually a little more heavy duty, especially the more expensive relays. And then these relays right here are going to be for everything that I have in there. And as of right now, this one is going to power all the USB chargers. It's going to be what else? The cigarette lighter socket up there. It's also going to be the the control wire for the radio head unit. In other words, you got to have this. Okay, so this Pioneer radio that I have, basically, it has two wires. It has one that has to have power all the time, which I'm assuming the reason why is for the clock and keeps all your settings good. And then the other wire is the one where you turn on the switch or accessory and it says, hey, somebody's in here, go ahead and turn the actual unit on at this point. So it's like the wake up wire. Well, that one's going to be run through this one and again, as well as all the charging station that I have up there. So that's what that one's going to do. This one here is going to run the booster equalizer, my old-fashioned, old-school booster equalizer up there. And then this relay here is going to run the powered subwoofer that I have. So that's the subwoofer unit that's going to go underneath the seat or in behind if I can get rid of that gas tank, but it'll probably go underneath at least at first. And that there needs to be powered, but it will be done by there. And then there's also a same thing with that powered subwoofer. It needs to have a turn on wire, like one that, you know, senses that you've got your head unit on or whatever. I will hook that one up to the head unit coming up and down. But I'm going to, because that one there really doesn't have any settings. I mean, it has settings, but it's all done by knobs and dials and stuff. So once you set it, it's going to stay that way. So my thought is rather than keeping that a constant power source to that, I'm just going to have it, you know, turn on and off with a relay, which obviously will be done by the switch. And then this one over here, you can see I put one of these little mini ATO or whatever the heck fuses type holders in here. Again, I believe this is a 12 gauge wire as well. And this one here is going to be the constant power that goes up there for the radio head unit. So immediately as it comes off this big old bus bar, we've got some sort of fusing to protect that wiring the whole way. As you can see here, so this is the main wire right here going to the bus bar, coming, let's see, coming right over here to the hot side where the battery cable comes in. I mean, I'm not fusing that because it's just such a small distance of travel. Same with, you know, your big battery cable here, for example, right here, I guess. Here's your positive side comes down, you know, you don't fuse that typically. And this here is a short distance, so I'm not fusing that. I didn't fuse my alternator one wire coming over, although sometimes people say that's a good idea because if this thing goes into overcharge mode or something, this can protect your wiring from that thing blowing everything up. But it's kind of a 50-50 thing, I guess. People do it and a lot of people don't. But again, because it's such a short distance, that's kind of the reason why I'm not doing it. And yeah, it's kind of rubbing a little bit, kind of, but I'm trying to keep it floating here. Who knows, maybe when I swap it over to the other frame, I might do something about it then, but until then, no. You can also see here I don't have it fused to any of this because that's the reason why I bought these, is because they have the fuses in the top, but that does not protect you anything here. So, you know, somebody comes inside this hood here and starts, you know, getting stupid and stabbing into that and hitting ground or whatever. Yeah, they could do some damage, but who the hell's really going to do that, right? And then, of course, you can see this relay is also, again, a very short distance run over to here, and I don't have it fused. But remember, this one here on the outside of it, as in like going over here to these relays, again, another short run, and all it is doing is it's just powering up these coils on these relays. So I admit I don't have everything fused and protected, but again, it's really not anything outside the usual that you would normally see, especially a vehicle of this vintage. Because again, nobody hardly ever puts a fuse from the battery down to these kind of solenoids and, you know, all these little short runs here. So as long as, again, it's not rubbing, it's not to something sharp, you know, it doesn't get close to exhaust where it can melt, that kind of thing, you're going to be good. But again, I will admit that there are some people that talk about that you should put a fuse from the alternator to here. But again, the thing I'm going to say to that is, as I've got a 100 amp, one wire alternator, which is, you know, a smaller amperage alternator. And I don't have a whole crap ton of electronics in this thing. I'm really not too worried about it. If this were getting too close to the exhaust, or it were to, you know, bounce and rub and just do stupid stuff, then yeah, maybe I might consider it, but I would probably just do a better job of insulating it and keeping it protected from being rubbed on and protected, basically what I would probably do. So, but from here to all the way up and through all that stuff, and you got metal sharp edges and you got all that kind of stuff that are going to be inside, you know, the pillar and along the leading edge of the cab here and all that kind of stuff. Yeah, it's a really good idea to actually fuse all that stuff, because you never know when it's going to, you know, wear through all that stuff. And once again, it's one of the biggest reasons why I chose to pick this double insulated wire here, this underground direct bury wire, because you've got, again, the insulation over the wire and the extra jacket of insulation. So now, as far as the speaker wire that goes to all my speakers and everything, well, I'm going to use 16 gauge, I think, is what I'm going to use for a lot of my speaker wires, for most of them, which is way bigger than what you need. 20 and 18 is most common, but I'm going to do 16. And also the stuff that, if you've ever looked at those speaker wires that you can buy, typically they're very, very thick, the insulation. They're meant to be, drawn through places where you're going to have sharp edges, and it does a really good job of protection. So that's why I'm going to use that. But also, in other terms, I plan on covering that stuff. I might even do that with this, by the way. When I get all this done, I might actually go and buy that 3/4 like fabric wrap and put over the top of all of that. And then also, not sure if I'll do it as it goes up into here. If that were just, one single wire with its own insulation jacket, in other words, without that yellow jacket over the top of it, I probably would try to put some sort of fabric or electrical tape or something around it as it goes up there. But because I'm going to be using that stuff to go up and down there with that extra secondary jacket, I'm probably not going to do it. Once it gets inside, you'll never see it, and nobody will care, for that matter. And it's very well insulated. For underneath the hood here, of course, that black stuff would actually cover that up and make that look a lot nicer. Although it is a little bit more colorful now with the yellow wire, but whatever. Probably can't cover all that up unless I build a cover for that, which I might do that. But again, that's not going to happen until I get it swapped over to the other frame. So, man, this video was long, and I hope it didn't bore you at all. But just, kind of going over everything that I've been doing and why I'm doing it this way, hoping that you guys were, learning something from it. If you got comments or questions or whatever, go ahead. I'll try to, this stupid YouTube and Rumble and that kind of shit, they don't really give me good indication that people are commenting. So I do apologize if I don't get back to you if you do have a true question or a comment or whatever. And if you're going to be a commie, if you're going to be a dipshit, if you're going to be an asshole, and you're going to say something just stupid, a suggestion, critical type, what do you want to call that? Criticism, fine. But if you're going to just be a dick, then, go be a fucking dick someplace else. Because I really don't have time for your shit, and I don't really even fucking care. Your opinion matters to me, as you can obviously tell. But in the meantime, because I'm just so done. I'm just so done with all the stupid bullshit that's going on in the world. Keyboard warriors, blah, blah, blah. I'm just so done. I'm just so done with idiots, okay? And if you happen to be one and you feel like that was meant for you, wear that shoe, lace it up, and wear it, okay? Lace it up and wear it. That's all I can say to you. But if you're not easily offended, well, thank God that you are still kind of normal. But if you are offended because I just said something that you don't even know was directed at you, well, can't help you. Anyway, like, subscribe, rumble. Come back for more, because I'm always going to have more for you. And we'll see next time as I start hooking it up from there, going up to there, and powering it all up. And then we'll start closing all that stuff in. Maybe. Actually, I've been thinking, if I'm going to move this over, I might even just leave all that stuff exposed up until the point I get it swapped over, and then close it all in. But I just want to get it hooked up and get all the speakers in, because I want to drive this, and I want to enjoy it a little bit while I'm building that frame over there, and obviously getting this one done. So, all right, guys, thanks a bunch, and we'll see you. And if you're offended, fuck y'all. Okay? Have fun. Bye-bye.